it's important that you understand what the definition of quality is from the PMBOK guide. And the PMBOK guide defines quality as conformance to requirements. If your project delivers the end product that satisfies the requirements as stated for the project, i.e. that satisfies the scope statement, that you deliver each and every component that's defined in the scope statement, then you have delivered a quality project because it conforms to the requirements, provided it meets the second criteria as well, fitness for use. Delivering a product that conforms to requirements that's unfit for use because it's unsafe structurally, that's unfit for use because it's full of bugs, that's unfit for use for any of a variety of reasons is not the definition of quality. So again, PMBOK guide defines quality as conformance to requirements, satisfies the project scope statement, and is determined to be fit for use by the business. As just mentioned, the PMBOK guide has its own definition of quality. Conformance to requirements, fitness for use. That's not to suggest it differs from, is unique from, any of a number of different quality standards, and I've listed a few here, whether they are specific standards or they're specific well-known experts in the quality field. There are certainly a wide variety of quality standards, quality benchmarks available in the industry. The PMBOK guide strives to be consistent with all of these processes, all of these quality statements, with its simple statement of conformance to requirements and fitness to use. The PMBOK guide's definition of quality is focused on customer satisfaction. Ensuring that the product that you deliver satisfies the business expectations, ensuring that the project that you complete satisfies all of the expectations, all of the requirements as defined by the customer, and the customer is satisfied. Another key premise of the quality process as defined in the PMBOK guide is prevention versus inspection. The PMBOK guide is focused on building prevention into the project plan to ensure that you're doing the right things right the first time, as opposed to potentially a more traditional approach to quality where you inspect after the fact and reject those components of the project that don't meet the quality specification. So again, customer satisfaction, building the right thing with a focus on prevention, ensuring they're doing the right things right the first time with an obvious focus on continuous improvement. So it's with its very broad definition of quality, fitness to requirements, conformance to requirements rather, fitness for use, the PMBOK guide is consistent with the approaches defined by these standards and these industry experts, with its focus on customer satisfaction, focusing on prevention, building the project plan to ensure that the quality processes are included in the project plan, with a focus on continuous improvement, that we're learning from our mistakes and we're improving the process, is the focus of quality as defined in the PMBOK guide. Now it's time to start to explore the various components of the PMBOK guide and the quality process defined by the PMBOK guide. The first step in the quality process as defined in the PMBOK guide is quality planning. Defining the quality standards, identifying the level of quality, identifying the processes that must be included in the project to ensure the project delivers to the quality expectations. And different projects will have different quality expectations. A life-critical, a life-threatening project, rocket launches, shuttles to the moon, control systems for nuclear power plants. These are life-critical, life-threatening applications. They must have extremely high, extremely rigid levels of quality defined in the quality plan. A project to develop a conference room scheduling system to ensure that the conference room in your organization isn't double booked may not have, and I would suggest should not have, the same level of quality built into the project plan. That may be acceptable that there may be a bug. It may be acceptable that the room gets double booked on certain occasions after the third or fourth cancellation. Therefore, the quality expectations for the conference room scheduling system will be very different than the quality expectations for the mission-critical, life-threatening application. You need to understand what the customer's expectation for quality is going to be. You need to understand what the customer's expectations for grade is going to be. Or grade, another term, is degree of functionality. How many bells and whistles? How much additional functionality is required for the project? That's grade. That's what the final deliverable is going to look like versus quality. What's the customer's expectation for quality? What is deemed an acceptable project? Is the project acceptable if it is 100% fault-free? And I would suggest in most projects we deliver in business today, the expectation of 100% fault-free is an unrealistic expectation. Time is money. Time spent on ensuring each and every piece of your project is 100% fault-free is potentially time that is not good investment for your organization. And as we'll discuss a little later in this nugget, there may be instances where applying an 80-20 rule, applying 80% of your quality process to the 20% of the function that delivers the most business value may be appropriate. I worked on a project once where we delivered a marketing analysis report to the business on a weekly basis, and the customer's expectation is this marketing analysis report would be delivered by noon on Wednesday. That was their expectation of grade. That was their expectation of what was required. The report delivered by noon on Wednesday. Their quality expectation was that the report would be 80% accurate. They were happy if we could produce this report by Wednesday at noon that was 80% accurate. Their definition of quality was 80% accurate. Now you may think, wow, what kind of report would that be? What good is a report that's 80% accurate? Obviously the customer would be ecstatic if the report was 100% accurate, but they understood that we had to get sales figures from a large number of stores, from hundreds of stores, that there would be issues getting the sales figures from 100 stores as of midnight the night before, prepared, consolidated, gathered, and distributed for noon the following day, a 12-hour window. If the store had problems, if power failures existed, if communications channels were down, there were all kinds of variables that could result in us not being able to produce the report at 100% accuracy by noon. So therefore, the customer's expectation of quality was 80% accurate, where the grade was the reporting of the sales figures for the past week for as many stores as possible. You need to understand what the definition of quality is going to be. What is their measurement of final project acceptance? If you buy a new home and you go in and do your final walkthrough for the new home, does that home have to be 100% perfect? What if there's a paint chip on a piece of finish going into the kitchen? What if there's a piece of trim missing from one of the closets in the spare bedroom? Would you be willing to accept the home if there were 2 or 3 or 4 or 5 of these minor flaws, with the expectation that the flaws would be resolved, would be fixed within a 1 or 2 week window? Again, that's your definition of quality. So it's absolutely important that you understand what the business's expectations of quality are going to be, how much tolerance they have for errors, for flaws in the final delivery. Again, recognizing that time is money, and the quicker we can get our project completed, the quicker the business is going to realize benefit from that project. There may be instances, again, where the 80-20 rule applies, and you deliver the project with somewhat compromised quality standards. You need to ensure that you're building quality into your project. If your expectation is the team will do inspections, if the team will do walkthroughs, you as a project manager must ensure there is time in the project plan, that there is time allocated to each team member to participate in these walkthroughs, to participate in these inspections. If you don't build the time in to participate, if you don't build that into the project, if you don't build that time into the project plan, to give the team members time to participate, to time to complete these walkthroughs and inspections, your quality process is not going to happen. The quality planning process starts at the top. The quality planning process starts with you, the project manager. You need to understand what the quality standards are going to be, what the business's expectations for quality versus grade are going to be, and then you need, and I would like to re-emphasize this, you need to build the quality into the Microsoft plan. You need to build the quality into your project plan to ensure there is time, there are tasks in the plan that the team members can use, that they have relief from other project delivery responsibilities to participate in the quality activities that are defined for your project to ensure, again, that your final product is delivering to the quality expectations for the project. Consistent with the process of building quality into the plan, let's focus a little bit on prevention versus inspection. Prevention is the built-in. Prevention is the walkthroughs. Prevention is the inspections, the tests. Prevention is doing the right things right the first time. If we look at a well-published graph in terms of the cost for fixing problems found throughout a life cycle, if we find the problem during requirements, it costs $1 to fix. If we wait is the wrong word, but if we don't find the problem until we're in analysis, it's going to cost $10 to fix. If we don't find the problem until we're in design, it's going to cost $100 to fix. If we don't find the problem until it's in development, it's going to cost $1,000 to fix. If we don't find the problem until it's in implementation, it's somewhere way up here off the graph at $10,000 to fix. This is a well-published graph, well-respected in the industry, and truly reflective of the costs, why there is so much benefit to prevention, doing the walkthroughs and tests early in your life cycle, as opposed to waiting for the testing phase, which happens right here between development and implementation. We actually do the testing or the inspection, and you start finding the problems where they cost thousands to tens of thousands of dollars to fix. Why is that? If we identify a missing requirement during requirements definition, it's probably as simple as adding a paragraph, adding a bullet to a requirement specification document that says, in addition, the final project must satisfy A. If we don't find it until we're in analysis, work has been done, other requirements have been analyzed, you may have to go back and backtrack and fix some other decisions that have been made to resolve, to add the extra functionality for the missed requirement. Similarly, if we don't find it until we're in design, at the $100 level, we're now going back, having to rework and potentially even redesign components for our project to ensure the new requirement fits in, on through development, where we have to undo some work that's already been done for the project, and then we have to redo, and so on. So it's very easy to see how this exponential curve is reality, how this exponential curve can truly affect our project, why it is so important to build quality into our plan to ensure that the time for the walkthroughs and the tests happen early. And that's the key. The prevention is early detection, where inspection is the traditional testing, which happens later in the project when we finally have a final product that can be tested. With the completion of the quality planning process and the development of the quality management plan, we go into actually delivering on the project and actually ensuring the quality processes are followed. The first step for doing that is quality assurance. Quality assurance has two main components: ensuring that we're doing the right things and ensuring that we have a quality improvement process in place on our project, that we're doing things better as the project progresses. So doing the right things is all about ensuring that the activities defined in your project plan, that the activities defined in your quality management plan are adhered to by all team members for the project. If the project plan says participate in walkthrough, if the quality management plan says at minimum of 5 team members need to participate in each walkthrough, quality assurance ensures that A, the walkthroughs take place as defined in the plan, and B, that the right number of team members participate in the walkthrough. If you have a walkthrough that's only attended by 1 or 2 participants, the walkthrough may not be as beneficial, as many issues may not be identified in the walkthrough because you don't have the benefit for the right number of team members participating in the walkthrough. So again, quality assurance is all about doing the right things as defined in the plan, as defined in the quality management plan. Quality assurance is about reducing waste, doing the right things right the first time. Quality assurance is ensuring that non-value added activities are not contained in the project. Non-value added activities are not contained in the project, but all of the right quality added activities are in the plan and that you're doing the right things. Then we need to step back and review, are the right things as defined in the plan, as defined in the quality plan, are they truly the right things, or is there potential for doing things better? Maybe 6 team members is too many. After reviewing several walkthroughs, we determined that, hey, it doesn't appear that we need 6 team members to participate in a walkthrough. Potentially 4 is the right number. So you review your quality processes, you determine whether in fact they are contributing effectively to the project betterment, and you make changes. So it's continuous improvements. Making sure that the quality process is truly value added, that the quality processes defined in your project will ensure that the final product meets requirements and is fit for use. It's all about doing the audit. There is an element of policing, and I know that's a nasty word in most people's vocabulary, but there is an element of policing in the quality assurance process. We do the audit, and we ensure that the steps defined are being followed. Again, I know I repeat myself, that we defined walkthroughs are to happen, and we defined walkthroughs need to have 6 people. The audit reviews that, ensures that is taking place, and then with our continuous improvement process, we make improvements by reducing the number of participants down to 4, or whatever the appropriate numbers will be. Often, the continuous improvement is the root cause analysis. Why are problems being discovered on the project? Why are we identifying 3 and 4 and 5 errors per walkthrough? Are the requirements incomplete? You do the root cause analysis as part of doing the quality assurance process to ensure that all actions on your project are meaningful and that all actions on your project are contributing to the final deliverables that will be signed off and approved by your sponsor. The next and final step of quality management is quality control. Quality control is all about ensuring we're producing the right results. Quality control ensures that the deliverables being produced, that the work products being produced by the project are providing the right results. The fitness for use, that the product of our project will in fact satisfy the business requirements and that it is usable in the organization. Quality control is validating and reviewing that we're producing the right results to satisfy the business requirements and that it is fit for use. Processes used in quality control: testing, reviewing the work, testing it, validating it, ensuring that it works. Inspections, validating that it follows standards. Inspections, validating that it follows proper defined procedures for your project. Whether you're constructing project, whether you're constructing code, you're inspecting to ensure it follows the standards for your project. Sampling, reviewing work, doing random sampling to make sure that there are no errors that are not being caught by the regular testing process, and potentially statistical control to ensure that, again, you're doing the proper sampling, the proper testing, the proper inspection to ensure that the quality control, that the production of the right results satisfies the requirements for your project. There's a large number of techniques that can be used in quality control, and we'll review a number of these techniques. One common technique used in quality control are cause and effect diagrams. Another term often used for these diagrams is the fishbone diagram, obviously because it looks very much like a fishbone. In a cause and effect diagram, you understand that you have a negative effect on your project. Let's say you have bugs in your project. You're delivering defective code for your project. Then you go back and you look at the causes. What are the causes? Cause A could be training or lack of training. Cause B could be tools, that you don't have the right tools for the project. Cause C could be, cause D could be, cause E could be, cause F could be. So you'll go through and do a brainstorming session to understand what the various causes could be of why bugs are going to be introduced into your final project. And then you'll go through and say, okay, one of the causes can be training. Is this truly the case? Do I have a training shortfall? What can I do to improve the training situation for my project? One of the causes can be tools. Do I not have the right tools? Do I need to buy more tools? What can I do to improve this situation? And by going through and doing the specific cause and effect understanding, you may be able to focus that says, no, training, I reviewed training, and it certainly is not the problem. My team says it's not a training issue. I've looked at tools, it's not tools, but hey, here is a possible cause. We don't seem to have any recourse to that. No one has any justification to it. So therefore, that is a cause you can look at as part of your quality control process to ensure, to define what you can do to improve, eliminate cause E, which will affect the removal of the bugs from your final system. Another very common technique used is the Pareto chart. The Pareto chart is used where you can identify specific problems. You can categorize defects or problems related to your project into a number of categories. For simplicity, I've just labeled them A, B, C, D, E, and you can measure the number of defects associated with each one of the problems. So in this case, we see problem A is resulting in 4 defects, and that could be 4 defects per hour, 4 defects per day, 4 defects per release, where problem B is resulting in about 3.5 per release. Problem C is resulting in 3. D has dropped way down to 1, and E and onwards are resulting in less than 1 problem per release, per week, per whatever our measurement period is going to be. The purpose of the Pareto chart, the focus of the Pareto chart, is the application of the 80-20 rule. If you can identify the 20% of the problems, meaning A and B, and possibly C, that are causing the majority of your problems. So with these 3 problems only, A, B, C, we have caught the majority of all of our problems. If we focus on resolving problems A, problems B, and problem C, we're going to spend 80% of our time focused on resolving those 3 problems. But by doing that, we're dealing with the majority of the problems, and the others, the D, E, and so on. Yes, in an ideal perfect world, it would be nice to be able to eliminate them all, but because, as we discussed earlier in this nugget, time is money, there was always a focus on getting our project delivered as quickly as possible. If we can eliminate A, B, and C, we have dealt with the majority of the problems. So we're going to spend 80% of the time focused on the 20% of the problems, but the big hitters that's going to ensure our project is going to deliver more successfully, that in quality control, we're focusing our time in the right areas. A quality control technique used when you can take many measurable evaluations for your project is a control chart. With a control chart, you establish the midpoint, the perfect point. If every process in your project was 100% every measurement would be on the midpoint. You then establish a high point that says any measurements above this high point are deemed to be out of tolerance, and therefore appropriate actions must be taken as part of project control. Similarly, for the low limit, any measurements before the low limit are out of tolerance, and therefore, again, quality control measures must be taken to ensure the project is put back into track. So as you take your individual measurements, you plot them, and you say, measurement, fine, it's within my limits, measurement, fine, within my limits. And as we're going on, we're seeing all of the measurements are within the limits until we reach this point in time. We've done a measurement, and it's below the lower limit, so we have to take corrective action on behalf of the project to correct the action, and we see our corrective action is improving it, but all of a sudden it's improving it to the point that we have now exceeded the high limit. So again, more corrective action needs to be taken to ensure that the process is reversed and that we go back and start to trend back to the midpoint. Another common approach used in control charts is the rule of 7. So if you have 7 consecutive measurements trending in the same direction, that also is a potential indicator of a potential out of tolerance situation. As we saw here, we had 1, 2, 3, 4, 5, 6. In this case, we went out of tolerance before we hit our group of 7. But if we see 1, 2, 3, 4, 5, 6, take one more measurement at 7, again, we have an absolute tendency that if we don't take corrective action, in all likelihood, it's going to continue in that direction and result in corrective actions. Once we hit the low limit, it would be better when we have 7 observable measurements in a consistent direction to take action at that point to remedy the problem, and then maybe our remedy can keep us closer to our midpoint. Probably the most common quality control process discussed today is Six Sigma. Sigma is a Greek term for standard deviation. Six Sigma and the measurement of quality related to Six Sigma is all based on a traditional bell curve. So if you assume all errors, all defects caught on your project are within a standard bell curve, that most of the problems occur near the midpoint for our bell curve, and as we go farther out on the bell curve, the number of errors get fewer and farther between. And sigma is the Greek term for standard deviation, so 1 sigma consists of catching the errors, resolving the errors related to 1 standard deviation plus or minus from our bell curve. 2 sigma is at the plus or minus 2 standard deviations through 3 sigma through 6 sigma. 6 sigma is the term most organizations strive for in terms of the quality process. Put this way, if 1 sigma, 68.26% of the problems are within 1 deviation, meaning you're still leaving room for 32% of problems to be realized for your project. If you go to 2 standard deviations, you're catching 95% of the problems through the 3, which is 99.73, to the most common 6 sigma, where you're catching 99.99% of all problems associated with your project. To put that another way, if you're at 6 sigma, there is 1 defect for every 10,000 units produced by your project. So if you were producing widgets and your process is at 6 sigma, you only have 1 defect per 10,000 widgets that your project, that your organization produces. If you were at 3 sigma, it's 27 defects per 10,000, and on as you go up through the process. So 6 sigma is nothing more than a quality process where you try to refine your quality system, your quality control process, to ensure that you're catching all of the errors farther out in the bell curve, that you're striving towards perfection, that you're striving towards, if you're going for 6 sigma, the 99.99% resolution, or 1 defect in 10,000. Again, time being money, that may not be appropriate for your organization. Maybe 3 sigma is more appropriate, where you're catching 99.73% of the problems, or numerically you have 27 defects out of every 10,000 measurements made by your project. There are many other quality control tools that are appropriate for use on projects, and I'm including them here in this nugget to ensure you're aware of all of the terms as they may appear on the PMBOK guide tests, your PMP certification test. Other quality control tools may be run charts, scatter diagrams, sampling, inspections, defect reviews. So again, be aware of these other terms. The ones that we've discussed in more detail are the more common ones, the more common approaches you would use on your projects, and the type of questions that you will more commonly see on your PMP prep. But be aware that run charts, scatter diagrams, sampling, inspections, and defect reviews are other quality control tools that may be appropriate for your project and may appear on the PMP exam. So in conclusion, for project quality management, it's all about understanding the business's expectations for quality. Understanding what their expectations for quality is a report delivered on time that's 80% accurate, their definition of quality. What is the project's definition of quality? Once you have the solid definition for quality, you then need to plan it in, build it into the plan. By having the tasks in the plan, the team has the task assignments, the team has the charge code with which they can charge the time they spend on quality processes to ensure that the quality plan for the project is enacted. Then you need to perform the quality assurance, making sure you're doing the right things, and performing the quality control, making sure the final deliverables are appropriate for the project. And part of any good quality control program for a project is the continuous improvement process, where you're reviewing through the quality assurance process, the quality processes themselves, and making any improvements along the way. You need to test and validate the quality process. You need to test and validate the quality and the final product to ensure it satisfies requirements and that it's fit for use. You need to deliver what you promise, but you need to deliver only what you promise. So as you're defining your project plan, ensure that you have the appropriate steps to deliver everything that's defined in the project scope. And then during project delivery, ensure that you're only delivering what is contained in the project scope. One of the biggest issues that can happen with quality control is the overall concept of gold plating, or delivering more than what's promised. The problem with delivering more than what's promised, the problem with gold plating is, A, time is being taken away from the proper quality assurance and proper quality control processes, ensuring you're delivering the right process. And by delivering extra functionality, there are extra pieces for your project that can have defects in them